Virtual networks, VNets in Azure, are fundamental building blocks for your private network in the cloud. They enable many types of Azure resources, such as VMs, to securely communicate with each other, the internet, and on premises networks. VNets provide isolation, segmentation, and security, allowing you to create a network topology that closely resembles a traditional on premises network. VNets are crucial for establishing a secure and efficient cloud environment. They allow you to segment your network, control traffic flow, and implement security policies. By using VNets, you can ensure that your resources are isolated from other tenants in Azure, providing a secure environment for your applications and data. To create a VNet, you need to define its address space, which is a range of IP addresses. This address space is divided into subnets, which are smaller ranges of IP addresses within the VNet. You can create a VNet using the Azure Portal, Azure CLI, or Azure PowerShell. Each method involves specifying the address space, subnets, and other configuration settings. Subnets are segments of a VNet's address space that help organize and secure your resources. Each subnet has its own range of IP addresses and can be associated with network security groups, NSGs, and route tables. Configuring subnets involves defining their address range, associating them with NSGs and route tables, and configuring any additional settings such as service endpoints. NSGs are used to control inbound and outbound traffic to network interfaces, NICs, VMs, and subnets. They contain security rules that allow or deny traffic based on source and destination IP addresses, ports, and protocols. By associating NSGs with subnets or NICs, you can enforce security policies and control access to your resources. Route tables contain routes that define the path network traffic takes. User-defined routes, UDRs, allow you to customize the routing behavior for your VNets. By creating UDRs, you can direct traffic to specific virtual appliances, on-premises networks, or other VNets. Configuring route tables and UDRs involves defining routes and associating them with subnets. VNet peering enables you to connect VNets, allowing resources in different VNets to communicate with each other. Peering can be established between VNets in the same region or different regions. It provides low latency, high bandwidth connectivity without the need for a VPN gateway. Configuring VNet peering involves creating a peering connection and configuring the necessary settings. To connect VNets to on-premises networks, you can use VPN gateways or Azure Express Route. VPN gateways provide secure, encrypted connections over the internet, while ExpressRoute offers private, dedicated connections. Configuring these connections involves setting up the gateway, defining the connection parameters, and establishing the connection. VNet to VNet connections allow you to connect VNets without using a VPN gateway. This is useful for scenarios where you need to connect VNets in different regions or subscriptions. Configuring VNet to VNet connections involves creating a virtual network gateway, defining the connection parameters, and establishing the connection. Service endpoints and private links provide secure access to Azure services. Service endpoints extend your VNet's private address space to Azure services, while private links allow you to access services over a private endpoint. Configuring these features involves enabling the service endpoint or private link, defining the necessary settings, and associating them with your VNet. Monitoring and troubleshooting VNets is essential for maintaining a secure and efficient network. Azure provides tools such as Network Watcher, which offers capabilities like packet capture, connection troubleshooting, and network performance monitoring. Using these tools, you can identify and resolve issues, ensuring your VNets operate smoothly. Following best practices for VNets helps ensure a secure, efficient, and scalable network. These practices include using NSGs to control traffic, implementing route tables and UDRs for custom routing, using VNet peering for connectivity, and monitoring your network with Azure tools. By adhering to these best practices, you can optimize your VNets for performance and security. Creating and configuring VNets and subnets is a critical skill for Azure administrators. By understanding the concepts and best practices, you can design and manage a secure, efficient network in Azure. Next steps include exploring advanced networking features such as Azure Firewall and Application Gateway to further enhance your network security and performance.